We got some good talks today still, so I really appreciate you guys continuing to hang around and pay attention. First up is Matthias. I try to be close. And he's going to talk to us about the API for the LabVIEW Application Builder and how it works into a continuous integration and continuous deployment scheme. And we're going to hopefully become this much closer to an expert today. And he's going to tell us a little bit about himself and then give a presentation on it. So let's welcome Matthias.
Thank you for being here. I know it's Thursday morning for everyone, even for me. So I'm going to try to not be much boring, so don't fall asleep. So my name is Matthias Bolo. I'm the founder of BODs. It's an alliance partner company based in Quebec City, Canada. So we do mainly LabVIEW consulting, LabVIEW development, specialization in OOP, SQL integration, hardware integration, of course. We design custom APIs. And we tend to specialize in continuous software deployment, project management, and we also do a little bit of training, custom training. BODs released 2 tools in the LabVIEW Tools Network since a couple of years. BLT, you probably heard about it, for managing the deployment of your LabVIEW executables, licensing your LabVIEW executables, and tracking your LabVIEW executables and deliverables. And Controls Generator for LabVIEW, very simple tool. You work with your graphic designer, you get your pictures, and then it's going to build your custom controls in a couple of clicks and automatically change the colors and things like that. So feel free to try them. They are free to download on the Tools Network. All right, is this presentation for you? I hope it is. If you spend too much time to create builds versus developing your code, I think you are at the right place. Obviously, we want to focus our time on developing features and not building and debugging. Same topic, you want to accelerate delivering of new features, patches, fixes to your customer. You or your customer, that's worst, often find out that you released something buggy. That's also where continuous integration will help. If it takes you more than 1 hour to release something that took you 10 minutes to implement, definitely there is a problem in the process. So again, continuous deployment and continuous integration is going to help. Basically, if you are interested in implementing your own continuous integration or continuous deployment system, you are in the right place. We're going to talk on a small piece of the continuous deployment system, basically the build part, but you have to start somewhere. Some requirements to understand that session. Of course, you have to be aware of VI server. There is a lot of use of VI server and LabVIEW scripting. Familiar with source code control, there is no continuous integration without source code control. So if you don't use source code control and you don't know what it is, maybe it's going to be hard for you. If you want to be frank with me, you should be convinced that LabVIEW code should be always componentized into libraries that you develop and maintain separately. That's also very helpful when you go into continuous integration process. So what you get out of this, all the source code I show today, you're going to be able to download it. I'll give the link. I developed even more demonstrations than what I'm going to show, so feel free to download and look by yourself, because I'm not going to show everything, we don't have time. I'll show an example of almost complete continuous integration solution that basically I used some customer projects, but I developed that really for that presentation today. These examples, I'm not going to give you the source code, of course, that's part of my business, so you can work with me. I hope you're going to get some new ideas to improve your own code management process. So let's talk about continuous integration first. Every step in your development workflow that you can automate, you should automate it. That way you can basically focus on building your feature and adding value to your product and your customer instead of focusing on building. Testing is one of the steps where automation is key. Automated testing allows you to implement new features quickly, so because you can always prove that the latest, basically the most important feature of your application always works. So it gives you all the confidence to experiment, develop. Yeah, it's too easy for us developers to say that when we make a change it doesn't break the app, and then we realize it did break the app. So continuous integration is the very first step for continuous deployment. Talking about continuous deployment, there are a lot of changes that can break your app and you don't realize it. If you think about external dependencies that you update, if you think about API changes, new server packages, new drivers, this is where continuous deployment shows all its power. Whenever your main code branch passes the test, it should immediately be deployed on at least staging environment, and even better, directly to production. When you have the master branch running on a staging environment, basically you can have your quality insurance or your development team go on that staging environment and always run the latest version available, or just open it and look at it. Questions so far? So if we look at the continuous integration flow, this is something most of you are going to be familiar with that. We have a team of developers and managers. The developers are going to submit their change on the source code control server. It can be Git, SVN, Mercurial. And you have a continuous integration that is going to continuously fetch the changes from the source code control server. Whenever there is a change, the continuous integration is going to build, run unit tests, integration testing, acceptance testing, whatever test you want to run. And if it passes or fails, it's going to basically notify the results of the test to the team, so you can make some adjustments. This is continuous integration. The difference then, if we look at continuous deployment, there is an extra step which is deploying to a staging or production environment. So that's the complete continuous deployment flow. There are different variations based on the type of testing you want to make, whether it's just unit testing, integration testing. So there are some variations, but the big picture is that. So who is working with a system like that already? Few people, few lucky people. Why to automate builds? Why would you want to automate builds? Any idea?
Because it's a fiddly, annoying, time-consuming task.
Yeah, it's really time-consuming task
and soul-sucking to boot.
And redundant. Yeah.
And he's repeat.
It's a repeatable process, so why not automating it? Absolutely. Everything that you can automate, you should automate it.
Austin,
yeah?
I was going to say, Austin can stay weird, but I don't want it in my code.
you don't want something weird in your code, but come to us team to enjoy the awareness.
Find problems early.
You find problems early, so you can fix them early, and your customers are happy early. Yeah. So yeah, we got pretty much all the points. Automating builds is really the first step when you want to move toward continuous integration and continuous deployment. You're going to eliminate a lot of redundant tasks. It helps your organization developing best practices in terms of software delivery. You accelerate delivering new features, patches, fixes to your end users. So basically, you improve the product quality, you improve the quality of your whole company process. It ensures proper dependency linkage, because with the continuous integration process, you can build on a dedicated build server, continuous integration server, so that way you ensure that when you change dependencies, basically if you don't know what changed and you don't prepare that, your build is going to fail. So having a dedicated system to build and not build a new development system is going to ensure that you are aware of all the dependencies changes. You keep an history of all the build and releases, so it's a lot easier to investigate and troubleshoot later because you know which version are your customer running, you know what you changed because you have continuous deployment and you keep track of your releases. You put nice notes in the release notes. You link that to an issue tracker, a bug tracker, so it's a lot easier to investigate. Basically, for all that reason, you're going to save time and money, and we all want to save time and money. Why would you automate build specifications, creation of the build specifications? That's a slightly different topic, but that's also what we're going to talk today. Yes?
So multiple people can do it, correct?
Yes, exactly. It's basically repeatable. Yes.
The build specifications of the project are actually quite fragile. They're easy to modify without even being aware that they've been modified.
Absolutely, yeah. They can be modified easily, and then it's really hard to find out what changed. Actually, you will have to do some diff on the XML project file, and it's not always easy to understand. Yes?
Why are you changing build specifications?
Sorry, can you repeat?
Why are you changing build specifications? Once you've done right, what do you do?
It's not really changing the build specifications, it's really creating them in a reliable manner and repeatable manner. So it's not really about changing them, it's more about creating them.
It's creating them right from the beginning. So for example, and not forgetting stuff. There are a lot of things on the build specification from NI where you need to remember to put if you want to do auto increment or not auto increment, if you want to put a shortcut, not shortcut, if you those details, all the checkboxes and things that you have to do on a build specification.
Yeah, it's pretty, I mean, it's not rare, but it happens often that you have to modify multiple times your build specifications before you can get what you want. Jim?
Are you saying that you want to automate build specifications by having kind of a higher level simplification or parameterization of your dev stuff build, where you're basically saying, hey, here's a folder, type component, these are all my settings that I want. Now build that into something much more specific that LabVIEW can understand.
Yeah, it's kind of that, yeah, you're right, and basically, so I go to the points, for me the main point, so eliminate redundant tasks, definitely this is something you do for each project, so if most of your projects are similar, you're going to eliminate redundant tasks. And it enforces software development packaging rules, so if you want to have a library, in your library to always have an examples folder, documentation folder, by doing that, you're going to make sure that your build specifications are always done the same way.
So I think you're saying you're templatizing the build specifications for, let's say, the use libraries in your organization.
Yes.
So that all different components have the same common global settings.
Yes. Yes. Another reason is you avoid developers doing build on their machine. We don't want developers to build on their machine because they say, hey, it's working on my machine, so it should work on yours. No, it's not always the case. So if you don't have any build specification in your project, if they are created at build time, you avoid that.
Why does the developer have a different machine?
No, but the dependencies, and it's the typical that I forgot to commit, or I thought I commit and pushed everything. So the step of going to the build server makes you pull and make sure that you actually, in fact, have everything.
Yes. So in the end, it kind of, again, improve the quality of your company process because you have some standardization, some build policies, some templates that you can reuse, maintain, version, track, so it helps improving quality. And definitely this is repeatable. So now let's jump into the topic, LabVIEW Application Builder API. So what you should know about this, it's not exposed on the LabVIEW palette, at least the one I'm going to talk about. You might know about the build function in the application control palette. There is the build, and they added 2 years ago the set build version. These are really high-level BIs of the application builder API, but there is a lower-level API that is not exposed to LabVIEW. So it's just available in the ILib, App Builder, and AB, and also API. It's designed on oriented object programming, so very easy to understand for people who already works with that, but most of it. It cannot execute in the LabVIEW runtime engine. That makes sense, okay? And I start allowing you to build products that can build LabVIEW applications. They're probably going to lose a lot of money. There might be changes between LabVIEW version, and these changes are not especially documented to the end users. So basically, use at your own risks. Okay, when you're going to change LabVIEW versions, you might change your code because there are some changes. It's pretty much stable since LabVIEW 2014. If you start to go before LabVIEW 2014, there are some significant changes. But since LabVIEW 2014, it's pretty much stable. There is a unique error code that is returned. Mine is 4500, no description or bad description. That's why I'm here. I'm going to try to give you some tips so you don't spend days and weeks to figure out why you get this error. And since LabVIEW 2014, it ships with examples, basic examples, but at least there is examples. When I started working on that API almost 10 years ago, there was no examples at all. So let's look at the structure of this API. As I said, it's OOP, so we have a class hierarchy. Whenever you want to do a build, you can build a target file or a source distribution. The source distribution is what you know as a source distribution when you go in your project and create a new source distribution. If you build a target file, it can be an application, PPL, or a web service. And part of the application, it can be an exe, a DLL, a .NET assembly, or an RT executable. The RT executable, it doesn't ship with LabVIEW. That API doesn't ship with LabVIEW. You have to request someone can add it. So if you are interested in building ERTXE with that API, you have to ask them. So it's just a screenshot of the VIs that you're going to find for the build class. So build VI, set version number, get broken VIs, preview the build, things like that. So who was aware of these VIs?
Were you aware?
Oh, yeah.
Was aware. Yeah, so a few people. So I'm gonna. You are
What did
in
it
the
take you to discover them?
Yes. Who was already using them? Who is already using them? Good. So the basic operation using this API, you open the build specification. So for that you need a project reference. So you first start by opening the project reference within the application in project open. Then you're going to do whatever you want to do, whatever method you want to do. So in this example, we set the version number. When you make a change in your build specifications, you use the commit build settings to validate those changes. Don't forget to do that, otherwise you lose your changes. The build VI is going to be the one to build the build specifications, and you close the build specifications function. Any question? So let's move forward with some demonstrations. If we go back to our picture diagram of a continuous deployment system, today we're going to work mainly on the build and the deploy. So first problem, each time you have a new library, you spend time to create build specifications, to figure out that maybe you made some mistake, and then you spend time to correct this mistake, verify. So I'm going to give you 2 demonstrations, one to create, edit, and build a source distribution programmatically, and another quick demonstration to automate the test of your build specification. I created those LabVIEWs. It's not like components, it's just that the example are for executable or in the library for executable. So it's not really the proper use of a library, but I found that easy to easily find the examples I need.
Could you
Yes?
using LabVIEW 2014, are you recommending that we also use LabVIEW?
No, you can choose any further version. It's going to be this. Basically, if you take my examples.
He didn't want to have to do back compared to every person that was going to be sending him an email saying, I'm still using 2015 or 20, yeah.
It's basically for you.
He's being nice.
If you want to use them in LabVIEW 2013, you're going to back convert and maybe you're going to have some BIs that changed the connector pane or things like that. But if you use that in LabVIEW 2017, it's going to work out of the box. So source distribution. Let's start with creating build specification. So you open the LabVIEW project. Open LabVIEW project. I don't need to show that code. I think it's pretty easy. Project open. Maybe you want to open the window as well. So you create the build specific, the new source distribution. So this VI is create new source distribution is basically not dynamic dispatch. Okay, in each class you're going to have a create for that specific class. Set build specification description if you want. Set the primary destination path where you're going to build, where your build is going to go. Then I'm adding a destination. So in that case, I want to build a source distribution. Usually a source distribution, you want it to look, the disk hierarchy, you want it to be similar as what you have on your source. So basically, I always add another destination that I name root, and I use the directory and preserve the hierarchy. And I'm going to put all my VIs into that root, because by default, the default destination of your build is not keeping the directory hierarchy. So I'm just adding a new one. It's the same destination path, but I set it to preserve the directory hierarchy. Set destination path. Then find project item path by path. It's very simple. Basically, I set the path of the main VI I want to include. And under my computer, I'm going to get all the descendants by type, so by VI, but you can do that for PPLs, or class, etc. And I just extract the PI reference. So then I have that PI reference, and I can add it to the always included, set its destination, I commit my build settings, I close my object, I close my project reference. Okay. So I have some sample projects here. For that example, yeah, it's not a library, it's a real application, but I use the finite measurement projects application. As you can see, I don't have any build specification right now. If I run this, it creates the build specification. And of course, it has my main VI as the always included. It has the description, everything I configure. Another example is to edit the build specifications. I can go quickly on that one. Maybe what you want to retain from that, when you configure your build specifications, you can select an entire project and add it to the always included. You can't do that with the API. You can't add a folder, virtual folder, auto-populating folder, whatever folder, you can add it directly. So you basically have to list all the items in the folder recursively and add them one by one. So when you look at the build specifications, you don't see just the folder, you're going to see all the files. That's not convenient, but this is how it works. Just examples of what you can find: set exclusions by path. You can do things like removing the block diagram programmatically of your VI, set some password for particular VIs, set the save settings, the version number, of course. You commit, you close, and you close your project. Questions?
So for the people who were asking before, you can recognize that all of those steps are steps on the build specification windows, right?
Absolutely, yeah. This is really when you go through the build specification window, as you do usually. This is pretty much the same. There are some specificities like this one, but otherwise for the same. So in this example, I'm basically adding a new folder for project documentation. I want to add my project documentation into the build specification, which is not the case. So if I run that, and I go to my build specification, now I have my documentation here. It's going to go into the roots and preserve the disk hierarchy. I'm not going to do a preview right now. It's going to take some time. So you can do that when you want. So basically, if you take
There's a question.
Oh, sorry.
Do you see any specific orders you have to follow? I'm sure there are some dependencies in the steps you need to follow.
No, you can pretty much modify it. So of course you don't want to set destination for a VI and you didn't create the destination. You're going to get an error minus 4500 with no description. So just the logical workflow, but you can set the build version number before you add any VI to your build specification. It's not a problem. So that example basically wraps the create build that I show you, the edit build, and the build VI. So I made the build VI command, so you basically have to specify the build object type. So this is a VI that you can reuse whether you build an executable, a source distribution, PPM. That VI is not only just calling the build VI, it's also giving you the exact same feeling when you build from LabVIEW with a progress bar that will show really what it's doing. Okay. So to do that, you open the build. There is a VI create progress bar events that is going to give you some events like new job, new item, error message, cancel. Cancel is actually something that it's an event that you want to generate when the user is going to click on the cancel button. So I'm not going to go into too much detail on that VI. Feel free to look at it. It's really the exact same behavior as what you have when you build from LabVIEW, where the cancel button is disabled at the beginning because you can't cancel from the beginning. So all that is made. And when the build is complete, you close the progress bar events, of course, and you close the build object. Okay, so that VI, you can use it for any build specification. It could be the only reason why you want to use that API, because you want to give some nice feedback to your user when you're building. And if you do that with the higher level BI that you find in the public, there is just no feedback. Any question? So this is how we create and build programmatically build specification. You can do some automated testing of the build specification using that API. So in this example, we open the LabVIEW project again. We're going to list the build specifications using VI server. So that's strange. It doesn't give you an array of build specs. It gives you an object, build specs, and then you're going to use the property on items. The type string is really the name of the build specification as it appears when you go into build specification, right-click, new. So for source distributions, it's really source distribution. Yeah. So you define a test. I use Traria, very easy to use and fast and not long to load. So I define my test for each bit specification, and then I'm going to go and test my bit specifications. So I open the source distribution, and I'm going to do 3 tests. I'm going to make sure that the target bit directory is right. So it's just an example. You don't want to do that way with a hard-coded path, just to give you an idea of what you can do. So we want to assert that we're going to build our HTML library into that path. That's an example. You can test if you enabled the auto-increment build version. And you can even test your build. Okay? If you do a preview, you don't build, but if there is an error, some broken VIs, etc., it's going to give you the error. Basically, the meaningful information in the error information resides in the first row of the error message. So you just isolate the first row and you return that as part of your test. There are some other VIs where you can basically get the linkage error, you can check the missing VIs, you can check the broken VIs. So there are other useful VIs in that API that you can use to do some automated testing. So let's run this. So I have a bad project. The build is missing one or more source files. Preferences, okay? Quick example of automated test. Question? Second problem. Whenever you add new features into your application, it takes time to go ahead, build, create an installer, release that installer. So that's something you can automate using that API. Okay. So 2 demonstrations, create, edit, and build executable programmatically, create, edit, and build an installer programmatically. I go very quickly on the executable demonstration because it's pretty much the same as for the other type of builds. However, it's different for the installer API, and I'm going to explain why. So very slightly different. This VI, as I said before, the create new EXE, there is a create new for each type of build. Then pretty much everything else is going to be a dynamic dispatch. So if you change that first VI for PPL, everything that works for PPL is just going to update and dynamic dispatch. Some differences, of course, it's add startup VI and not add always DB. There is also add always DB, but there is the add startup VI that, of course, doesn't exist for source distribution. Commit build settings and close. So edit, what did I put into edit? Yeah, just to know, look at it again, the same trick, you cannot add an entire folder to the list of inclusions.
So just, yeah, take this one from the top.
So for the people that just jump into the room, one important trick, you can't add an entire folder to the build specification using the API. You have to list recursively everything that is in that folder and include them one by one. Set exclusions if you want, build version number, again you commit, you close.
The installer APIs are in the same library as the building? It's separated?
It's separate. So the installer builder API, the installer API, it's in a different location. And it appeared in LabVIEW 2014. actually. There is no installer API before that version. VILib and installer builder. Okay. And there are some examples, and you're going to want to work with the classes. And basically, if you build an installer for Windows, you go into the Win installer, and you're going to find the class and all the methods. It's a little bit different because it's working with property nodes. So again, you open your project. This is a method, create new installer. You can programmatically retrieve the LabVIEW path based on the version you are working on. So here I'm just concatenating some strings to install into LabVIEW, VILib, my company, product name. Okay. So you set the default install directory, you set the installer destination, company name. In that case, I don't want to select any additional installers, so you set automatically select drivers to false. Then you get all the selected products, because by default it's going to, when you create an installer, it's going to select the LabVIEW runtime engine and maybe other things. So you get all of them, it's an array of objects. And there is a VI here, set product inclusion, and you put a false in it. Okay, so you just remove it. Again, there is a commit settings, we close. If I look into the build installer, so I open my installer, I set the product version, commit the settings, and here I'm using basically the build from the valid. Why? There is a build in the API, it's right there. It doesn't work for some reason when you build the installer, but when you try to launch the installer, it gives you that nice error message. So the workaround I found is that you build. Anyway, you don't have any progress bar events or whatever. So even if you wanted to use the lowest level API, there is no really added value. You can have progress bar right now. Questions? I could run them, but we're just going to lose time. I want to leave time for some questions. So since you can download all the code, you can run it by yourself and you'll see those. Okay, third problem. You are concerned about protecting your LabVIEW libraries. Okay, you don't want to rely on the password protection. We all know here that the password protection is not, can be easily cracked. Okay, you go on Google, crack the password protection, and very easy. I'm not saying you should do that, so this is something typically I do for BLT. BLT is also a licensing tool. I can't rely on the password protection. If people can be able to see how I'm doing the licensing, then I don't have any product. The big pain with that is when you want to do that for multiple LabVIEW versions. You have a library, you want to remove the block diagram, remove the source code, because this is the only way you can really protect your VIs. So since this is going to be compiled code, you have to do it for every LabVIEW version. So that's a really good reason to automate that. Okay, BLT works for all the 6 or 7 last LabVIEW versions, and I automated all that because I'm maintaining this for 32 bits, 64 bits, so it's basically building my source distribution 12 times. So demonstration. Okay, so here I have a simple front panel. You choose basically what LabVIEW version you want to build. You can build on a remote machine. Basically, we're going to open a reference to a LabVIEW application instance, So you specify the port of the VI server. I specify the LabVIEW project path, what type of build specification it is, the build version number, and the build specification name, and where I want to build. So I wrote some code so you can basically use some tags, build version, LabVIEW version, and it's going to automatically replace the path. It's not native, okay? I'm going to show you the code that does that, but it's kind of obvious. Okay, so for each build enabled, I'm going to open a LabVIEW reference. I got a question from Olivier the other day. Yeah, sometimes I'm doing some automated builds and LabVIEW closes the reference. You probably all realize that sometimes when you build, especially large applications, LabVIEW becomes unresponsive. And basically, LabVIEW might close the connection because it's unresponsive for too much time. So the quick trick here is to use the method connection responsiveness info when you open the LabVIEW application reference, and you can increase the ping timeout, the ping delay. So basically, you wait more before saying, okay, LabVIEW is unresponsive, I'm closing the connection.
Matthias, you're giving away the store.
You can set that to -1, and it just won't check.
So,
which I've been doing, and it hasn't screwed me. So
yeah, but if you do really LabVIEW becomes unresponsive for true, you're gonna wait forever.
well, if it becomes unresponsive, yeah, you're gonna wait forever. But if LabVIEW crashes, then it closes the connection, and you find out about it.
Absolutely. Yeah. So we open a reference, and I'm going to call this build to remote. It's not really aesthetic. You can't use this VI here when you're going to run the VI and directly use the connector pane. You can't do that because you're going to probably call a different LabVIEW version, and it's not going to like. It's not going to like that. There are some context issues. So you have to go that way, basically, set the control name of your VI. So if I launch that VI, this is really the VI that is going to do my build on my build server, and I'm going to programmatically open LabVIEW on that machine, programmatically call that VI, programmatically set the version, the project path, the build version number, everything, and run that VI. So that VI then is going to parse my tags that I showed you earlier to replace the LabVIEW version with the LabVIEW version, the build version with the build version, and generate a nice path. We set the destination directory. So this VI is really, it's what I showed you earlier. You open the build and you set your property, you commit, you close. I wanted some really simple examples. Of course, you don't want to open, close, open, close, open, close. I could do that in a single opening of my object. I set the version number, I build, and I close my LabVIEW project. And finally, I close my application, my reference to the application instance. Maybe we can run one. Oh, I should have disabled before. I don't have any start button, it just runs. Okay, so it opens the project, and you can see here the build VI. The cancel button is not enabled at the beginning because it's preparing the build. If it's too long, I'm just going to kill LabVIEW. Here, I'm assuming as well that LabVIEW is open, but you can also definitely programmatically launch LabVIEW.
For the build serving in this demo, do you just have multiple instances of LabVIEW running on your box? Do you use virtual machines?
So I use virtual machine. I have a single virtual machine where I have all the LabVIEW versions installed, 34-bit 32 bits, 64 bits, and each one of them has its own VI server port. Other questions on that example? Okay, I just have 15 minutes. I need to continue. Latest problem. It takes you more than 1 hour to deliver a patch that took you 10 minutes to implement. Okay, that's probably my favorite one. Also, you want your library. So basically, this is where you want to have kind of continuous deployment, continuous integration. So the demonstration is a continuous delivery of LabVIEW libraries.
Okay, unfortunately during the session at NI Week, we were missing time, so I didn't have the chance to go deeply into the demonstration. So I'm taking the time now to redo that demonstration offline. So this demonstration, again, is an overview of a complete continuous integration system, but it doesn't implement any testing. It takes care of building and deploying the applications. So here, our example is some instrument libraries. This is the source code of some instrument libraries that are well known, some driver instruments. This is the project, and we have 3 different libraries that are under some source code control, which is managed by SVN. We have this application that is written entirely in LabVIEW, and using some of the stuff that we previously showed in the session. Okay, so this is a continuous deployment server. Basically, the goal is to automatically trigger the build of our libraries and publish some updates to a package management server, deployment server, call it whoever you want. So if we go to the settings of this application, we define some configuration settings. So the SVN check period, every 60 seconds, we're going to check for the SVN if there is any new commit that are in the SVN. We specify which LabVIEW version we want to build our libraries, the SVN repository settings, the working directory, username, password, repository. And here, this is where we define basically the different products we want to build with this continuous deployment server. So we can define an alias, so for example, Agilent, and the library folder path, so the relative path under the SVN working directory where we have our libraries, and some component ID. This is a unique identifier that we can use with our installer technology. So how this works, when the developer will commit a change for one of those libraries, he will be able to basically enter some tags in the commit notes. Let's say --build --agilent -version 1231. So this is how the developer will only focus on implementing and new features and fixing the code. And as soon as he commits the changes with some specific tags, the build server, the continuous integration server, is going to get that changes, update the SVN, trigger the build, and push an update. If we go to the installer settings, this is where we define basically the installer that we're going to use to install the first version of our product, of our libraries. So this is an online installer. Here we are using some technology made by Qt, the Qt installer framework, to develop this installer technology and distribute our LabVIEW components. Okay, so this is an online installer. We specify in which directory we install the libraries. And we define the different packages, the release date, the version, and what is in that containing that packages. So basically the source files of each packages. Okay, so we have the Keithley and the Tektronix drivers. So we're gonna make an installer, and it's gonna basically compile the source of, I mean not compile, but package the source of all those components, those libraries, and publish them into a repository, and then the installer will be able to fetch this repository for the packages and install them. So let's generate an installer. And we put the installer on the desktop. So it's now packaging the data, and in a few seconds we're going to see the installer appearing on the desktop. Okay, so the installer is available here as a one file installer. So let's run it to see how it looks. Okay, so this is the setup screen. We specify where we're gonna install the libraries. What I didn't show before is that in my installer settings, I have some script files that basically here I'm installing the maintenance tool, the uninstaller tool for all my product, my libraries, but I have some script files for each component that specify where the location, where this needs to go. So the instrument libraries are going to go under the LabVIEW directory instrument lib. So if I look right now into my C drive, program files, national instruments, LabVIEW 2016, instrument library. Right now I have the Agilent, which is shipped with LabVIEW. So I'm going to install my libraries. You see that it fetched the online repository and found all 3 products that we've just built. I mean that we just released while building the installer. Okay, so you saw that in the install now are 3 libraries. Okay, so if I open LabVIEW 2016 now, and open a new VI, you'll see under the palettes that we have now our VIs, our libraries. So for example, the Agilent, we have the VI3 with all the VIs. So now I'd like to show you how to push an automatic update and to automatically update this VI, for example. So let's go into our SVN repository, into the source code of our library, for example, the Agilent. Okay, and I'm going to open the LabVIEW project and go into my VI3. And let's change the color of the block diagram. Okay, so this is the change that we just made into our source code. So let's save the VI, close the project, and we are going to do a commit of that change. So remember the alias when I defined my product here in my continuous deployment server, I define an alias for which basically library I want to build. So in my build text, in my build commands, in my commit command, sorry, I have this syntax to trigger build -- build -- the alias Agilent -- the version number -- nuts, and this is going to be the release nuts. So let's commit this. So now the continuous deployment server is going to check the SVN and find out about this new commit and trigger the build. Okay. So let's close LabVIEW here, everything to make the machine clean. And we can manually check the SVN here. I've made this button available for this demo. Okay, so it found the new build revision, changed VI block diagram color. and it's now connected to LabVIEW and starting the build. Okay, it built Agilent version 1001 and released the new version. So if I go into my release history now for Agilent, you can see that I've just released a new version. So now if I go to programs and remove programs, and I'm gonna find my product TS instrument libraries, and I'm gonna modify it. This is something that we could script definitely to check updates for automatically, but we just go into the control panel, add on remove products, and we're gonna check if there is some updates for our component. So you see that there is an update that has just been published, version 1001, and this is the change we just made, the developer just made, changed the VI3 block diagram color. So let's install this and finish. So now in LabVIEW, if I go to my instrument libraries palette, Agilent VI3, oops, sorry, instrument Agilent VI3, and I go and check this VI, you can see that my change has been implemented there. And if I look at the path of the VI, this is indeed the one that is located in the LabVIEW instrument folder, instrument lib directory. Okay, so this demonstrates how basically a developer can just focus on making the changes and push the changes in the source code control system, and a system like this continuous deployment server is going to be able to automatically do the build and publish it for the users. For convenience, in this demonstration, we use the same machine to be the deployment server, the build server, the developer machine. Of course, these are not good practices. In a real scenario, you have the continuous deployment server being a standalone machine. The build server can be the same machine as the continuous deployment server, or can be other remote machines, for example, a Linux build server for building Linux LabVIEW applications, and a Windows build server for building Windows binary applications. And of course, the development computers are the personal computers of the developers where they develop the code, and they should never build the code on their development computer, but only the build server should build the libraries and the code. This ensures that you basically know about your dependencies, and when you make a change to your dependencies, if you didn't install the new dependencies on the build server, your build are going to fail. Also, you could implement additional functionality to do some automated testing, and the automated testing server could be also another separate machine, and they are communicating through each other with web services or other network communications.
Okay, so just to recap what we did here, we submitted change, the continuous deployment server fetch the change, we did a build, and we deploy, and we can send an email when it's been deployed and built correctly. A few words about BLT, what it does that for executables only. Okay, it's on the roadmap to do that for libraries, PPLs, RTXs, etc. Right now it's just for LabVIEW executables on Windows. It manages the product releases and changelog, it creates one file installers, it licenses your application, it tracks whenever any of your customer is launching your application. When there is an error in your application, you are able to send emails with error notification and all the detailed error message to many people in your team. So feel free to look at the website. And we also have at StudioBots technology to manage SVN and Git repositories proactively with LabVIEW, and as also create online and offline installers with componentization and code signing certificate. take this one picture. This is the link to download all the material of this session. And before you go, please take the survey. And thank you very much. If you have any question, we still have a couple of minutes.